All right, now we're going to take a look at negative exponents. So before, when we were dividing powers with like bases, the exponent that was larger was always on top. So one question might be, well, what happens if it's on the bottom? Well, same idea, right? If we have 5 to the third divided by 5 to the seventh, we have two powers being divided. They have the same base, so that quotient rule still applies. We could subtract the exponents, but remember I said it's always the top minus the bottom. Even though in this case we have a smaller number on top, what's just going to happen is when we subtract the exponents, we end up with a negative exponent. So that's 5 to the negative fourth, okay? Another way to look at this is in this expanded form, just like we looked at a second ago, when we had, we have 3 5s on top, 7 5s on the bottom. Now before, all of our numbers on the bottom canceled out. Well, in this case, we have less of our base number on the top. So we're going to run out of 5s on the top before we do on the bottom, right? So this cancels out to 1, 1, 1. So I'm just left with 1 on top, right? Because I have 4 5s left in the bottom. If I have 5 to the third divided by 5 to the seventh, 3 5s on the top cancel out 3 5s from the bottom, and I'm left with 4 5s being multiplied together on the bottom. So they have to stay on the bottom of a fraction. They started at, they're down there. We can't just make it 5 to the fourth, right? 5 to the seventh divided by 5 to the third would equal 5 to the fourth. So if we flip these around, obviously it can't equal the same thing, right? Division doesn't work like that. I can't do 5 divided by well, that's a bad example. I can't do 8 divided by 2 and get the same thing as 2 divided by 8. It just doesn't work. So don't make that mistake. If you have, if you run out on top, you're going to have all of your base numbers on the bottom. So you have to remember to put that 1 there, and it's 1 over 5 to the fourth. Okay, these are both ways to represent 5 to the third divided by 5 to the seventh. Okay, so they're the same, two different ways of writing the same value. So 5 to the negative fourth is the same thing, or equals 1 over 5 to the fourth. And I have this little note over here. If the exponent is negative, taking the reciprocal of your number will make it positive. Okay, and that's important because whenever we're going to simplify expressions with negative exponents involved, they never want your answer to have negative exponents in them. The directions will always look something like this. Express using positive exponents. So they want you to take that negative exponent and change the value so that it's a positive exponent. All right, so how we're going to do that is by following this rule, which we just saw why that rule exists, because a to the negative n is the same thing as 1 over a to the n, right? If you think of a to the negative n being over 1, if we flip that, right, take the reciprocal, right, because any whole number over 1, you can turn it into a fraction just by putting it over 1. If we take the reciprocal of that and flip it, then the exponent magically becomes positive, okay? Not really magically. We saw why up here, right? The two different ways of writing it. So just kind of remembering that rule. If you want to make an exponent that's negative positive, you've got to take the reciprocal. If it's on the top of a fraction or a whole number, then it's going to have to go to the bottom, right? In the same idea, if you have a fraction where you have a negative exponent on the bottom, to turn it positive, you're going to have to flip it. It's going to have to go on top. Okay, so that's really just the trick with negative exponents. So let's take a look here. We got 4 to the negative 2. All right, well, 4 to the negative 2, and if we want to think of that as 4 to the negative 2 over 1, since they don't write it as a fraction, we can write it as a fraction just by putting it over 1. If we flip it, then our exponent is going to become positive. 4 to the negative 2 is the same thing as 1 over 4 to the positive 2, right? Mirrors this rule up here. Something to the negative exponent is equal to 1 over that same thing, except now our exponent is positive, which 4 squared is just 16, so we'll just go ahead and simplify that all the way, considering it said express using positive exponents and then simplify. Okay? Negative 3 to the negative 2. Well, that's going to be the same thing as 1 over negative 3 to the positive 2, right? And then negative 3 can stay there. It's okay to have negative base numbers. We just don't want positive we just don't want negative exponents. Okay, keep that in mind too. All right, and then we can go ahead and actually simplify this. 1 over negative 3 squared, negative 3 times negative 3 is positive 9. Okay, so negative 3 to the negative second power is a fancy way of saying 1 over 9. Notice how the answers are all the reciprocals of what we would get if the exponent was positive. What I mean is, if this were 4 to the positive 2, I would get 16. But since it's 4 to the negative 2, I get 1 over 16, right? The reciprocal. If this was negative 3 to the squared, it would be 9. But it's negative 3 to the negative 2. So it's 1 over 9. So on and so forth, right? M to the negative 3, that's going to be the same as 1 over m to the positive 3. And that's done because we don't know what m is. We can't simplify that any further. Okay, just applying that rule. Here's one. Don't let this one trick you. Remember, back in the first video, said the exponent only goes with what's directly in front of it. If the a and the b are not in parentheses, so just the b is being raised to the power of negative 1. Okay, so if we kind of think of this whole thing as being over 1, the b to the negative 1 has to come down to the bottom in order for that 1 to be positive. The a doesn't have a negative exponent, so it can stay where it is. And we end up with that. Or a over b. You don't really need the 1 since it's the same thing, but we'll write it. It might make us feel good for now. Okay. Here, we're already set up in a fraction, except now the negative's in the denominator. Well, that's okay. To make it positive, it's just got to take the reciprocal. So since it's already on the bottom, we got to move it to the top. So it's going to end up being x to the third over 1. Which is just the same thing as x to the third, so you don't even need the over 1 really. Okay, wherever it is, top or bottom, it just needs to go to the other place in order to turn the exponent positive if it's negative. All right, here, same kind of situation as number 4, right? 3c to the negative 5th, right? It's just the c that's being raised to the power of negative 5, not both of them, not the 3 and the c, otherwise it would have parentheses around it. It only goes with what's directly in front of it. These two things are being multiplied. So really, if we look at this if we write it as a fraction, anything raised to a power, negative power has to be moved from where it is. So c to the negative 5th has to go down to the bottom in order for the exponent to become positive. 3 didn't have a negative exponent, so it can stay where it is, and we get 3 over c to the 5th. Okay? So that's negative exponents. That's how to deal with negative exponents. Oops, I already did that. All right, so here's a your turn. Pause if you want to. I'm going to go ahead and write the answers. All right. If you're tuning back in, hopefully you're checking, hopefully you match. All right, just want to point something out on this guy over here, right? We ended up with, if we're looking at this as a fraction, boop, boop, right? Took the reciprocal, now it's a positive 3 as an exponent. And then negative 2 to the third power, remember that's negative 2 times negative 2 times negative 2, which we do that, we get negative 8. All right, and that's our final answer. Don't start making up rules and putting the 8 on the top because it's negative. All right, that's not how it works. All right, like I said, you're allowed to have a negative base number. You're just not allowed to have a negative exponent. So don't go making up stuff and just sticking the 8 on top for no reason. 1 over 8 is not the same. 1 over negative 8 is not the same thing as just positive 8. All right, nowhere near the same thing. Okay, and then in this one, remember, the negative 3 is just the exponent for p, not the 4. So the 4 didn't have to move, but the p to the third did, so on and so forth. Okay. I want you to give these a try. We'll do the first one together, if I can get my camera in focus. These ones down here just kind of combine a couple of the rules together. The product rule, the quotient rule, and now we've got negative exponents mixed in. All right, so give those a shot. So for example, here we've got 5 to the negative 2 times 5 to the 4th. I've got two powers with the same base being multiplied. So it's the same thing as adding their exponents. So that's going to be 5 to the negative 2 plus 4 is 2. So it's the same thing as 5 squared, which is 25. So fortunately for us, once we applied the product rule, the negative exponent kind of took care of itself. It went away, turned positive, so we didn't have to worry about it. All right. For number 2, and if you want to pause at this point, try to do the rest of them on your own just to see if you got them, then go ahead. I'm just going to keep going. All right. They're being multiplied, so I can add the exponents. Negative 3 plus negative 4 is negative 7. I would be done, except they always want us to have positive exponents in the answer. So therefore, I've got to change this so that it is a positive exponent. So that's actually going to be 1 over x to the 7th, because that's the same thing as x to the negative 7. All right. Whoops. 7 to the negative 2 divided by 7 to the 3rd. All right. If I'm dividing, I can subtract the exponents. So that's 7 to whatever negative 2 minus 3 is. So that's 7 to the negative 5th, which I can't leave as that. I have to change it to where all the exponents are positive, so I would have to take the reciprocal and put it 1 over 7 to the 5th as my final answer. Okay. Down here. All right. Couple things you could do, a couple ways you could think about it. I mean, you have to take care of negative exponents, you have to take care of the quotient rule, the division. It doesn't really matter which one you take care of first, as long as you do them correctly, you'll get the same answer. So here's what I mean by that. I'm going to go ahead and do the quotient rule and say, oh, well, I'm going to subtract the exponents, right? Negative b minus negative, or sorry, b to the negative 2 minus negative 3. If I subtract the exponents, remember, subtracting a negative is the same thing as adding a positive. Negative 2 plus 3 is 1. So I end up getting b to the first power, which is just b. Okay, negative took care of itself. If I had chosen to take care of the negatives first, and by that I mean maybe I looked at it and thought, oh, well, to make this a positive 3, it would have to move up here. And to make this a positive 2, it would have to move down here. So I could just take the reciprocal of the whole thing, and my exponents would now be positive. And then I could do the quotient rule. So b to the 3rd divided by b squared would then be b to the 1st, because 3 minus 2 is 1. These two b's canceled out 2 of those, right? And up with b to the 1st. So I got the same answer doing it both ways, right? It's whichever way seems less confusing for you, all right? Whichever way you like better. And then the last one, I got t divided by t to the negative 5th, right? So that's t to the 1st. So I can look at that as t to the, and then subtract my exponents, right? Which 1 minus negative 5 is the same thing as 1 plus positive 5. So that's t to the 6th, right? That would be my answer for that one. If you wanted to take care of the negative first, right? If you're like, well, if I just move this up here, then, right, t to the 1st, then the exponent will turn positive, right? And then t to the 1st times t to the 5th is t to the 6th over 1, which we don't have to write, but it's there. So for those last couple, it was just showing you that for problems where you have to do more than one thing, it really doesn't matter what order you do it in as long as you do it correctly. It's just a matter of which way is less confusing for you. Some ways are quicker than others, depending on where you start. Okay?